Hi, this is Songhee Ra, and today's lesson is about geologic timescales. We are going to be covering what geologic time is, why we need it, how it's divided, and the major main events of each period, what relative age and absolute age are. Geologic time is Earth's geologic history divided into different time periods. The geologic timescale was developed by scientists to organize and represent the evolutionary history of Earth. The timeline was created in the 1700s and 1800s by geologists to help them put different groups of rocks and fossils in order. This also requires to study the rock layers, fossils from around the world, and using relative age to try and put them in order. However, more recently, scientists also use radioactive dating to calculate the real age of a fossil or rock. We will be covering how you would use a relative age and radioactive dating to figure out the absolute ages in a separate video. Now, how is it divided? It is divided into eons, eras, periods, and epochs. Eon is subdivided into eras. Eras are subdivided into periods. Periods are subdivided into epochs, and epochs are subdivisions of a period. This is told in million years ago, meaning we would say that the Paleozoic era was 540 to 245 million years ago, or the Jurassic period was 200 to 140 million years ago. Now here on this page, on the left side, we can see a chart. On the top, we can see that it is divided into eons, eras, periods, and epochs. So in the Phanerozoic eon, it subdivides into the Paleozoic, Mesozoic, and Cenozoic eras. Then, in the Paleozoic era, it is subdivided into the Cambrian, Ordovician, Silurian, Devonian, Mississippian, Pennsylvanian, and Permian periods. The Mesozoic is subdivided into Triassic, Jurassic, and Cretaceous periods. Finally, the Cenozoic is divided into Tertiary and Quaternary periods. The graph on the left shows the percentage of each era. Cambrian takes up 88.3% of Earth's history. Paleozoic makes up 6.4% of Earth's history. Mesozoic is 3.9% of Earth's history, and the Cenozoic era, which is our present-day era, is only 1.4% of Earth's history. Now, let's move on to major events of the periods and the Precambrian era. The Precambrian era was around 4,600 to 540 million years ago. For this era, fossils are extremely rare to find. There are many anaerobic, heterotrophic prokaryotes that appeared around 3.5 billion years ago. However, photosynthetic prokaryotes appeared 3.0 billion years ago. Then, at around 2.0 billion years ago, the first aerobic eukaryotic cell was found, which is followed by multicellular algae that appeared 1.2 billion years ago. At this time, the only life that existed on Earth was only in the sea. The Paleozoic era. This era was from 540 to 245 million years ago. This era included the Cambrian period, the Ordovician period, Silurian period, Devonian period, Carboniferous period, and Permian period. The first period of this era was called the Cambrian period. This was from 540 to 510 million years ago. It has a nickname of a Cambrian explosion, as it brought great diversity in invertebrate life. Some organisms that were present during this time period were soft-bodied jellyfish, worms, and sponges, brachiopods with two shells similar to clams, and trilobites or orthopods, which were dominant. The next period was the Ordovician period. This was from 510 to 430 million years ago, and included a diverse marine invertebrate. These organisms dominated during this period. The ancestors of our modern-day octopi and squid were presented, along with the first version of the jawless fish. Silurian period was 430 to 400 million years ago. The Ordovician period's jawless fish was abundant, and now we are met with a new version, a jawed fish. We see a never-before-seen species, the arthropods and vascular plants. Or in other words, organisms that lived on land. (400 to 360 million years ago, was the start and end of the Devonian period. It was called the Age of Fishes. This period gets this name from the abundance and diversity of sea animals and organisms. Although the fishes dominated, there were still a gradual growth in organisms that lived on land, such as ferns, horsetails, wingless insects, arachnids, and amphibians. The Carboniferous Period was from 360 to 285 million years ago. At this time, we start having copious amounts of new organisms and a high amount of coal formed. We see our first seed plant that appears along with the amniote egg in early reptiles, and abundant sharks, amphibians, and winged insects. The Permian period started from 285 million years ago and ended at 245 million years ago. We all may know that the mass extinction of the dinosaurs in the Cretaceous period, but maybe not about the one in the Permian period. This time period included the largest mass extinction in Earth's history, where 95% of marine species disappeared. This led to gymnosperms and conifers being dominant. The next era. The Mesozoic lived on from 245 to 65 million years ago. The first of this era was the Triassic, the period we may all be familiar with the earliest dinosaurs' appearance. There are also other organisms that are survivors of the mass extinction that spread and colonized in new areas. While all of this was happening, the supercontinent Pangaea started to change. More specifically, the climate and ocean circulations changed. The remaining cyclads and conifers that were dominant during the Permian period were still dominant. This was also the start of the early rodent-like mammals, which were presented in the late Triassic. The Jurassic period was from 200 to 140 million years ago. This was the prime time for dinosaurs. They ruled the earth and was the dominant animal life on land. Many of the reptiles that survived the mass extinction evolved to have bird-like characteristics, making them part of the evolution of birds. Although life on Earth replenished, Pangaea begins to break apart around this time. the angiosperms also make its first appearance on land. The Cretaceous started at 140 million years ago and ended 65 million years ago. The dinosaurs from the Jurassic period were dominant until early of this period, but they were met with yet another mass extinction at the end of the period. However, this time, only 50% of all plants and animals species became extinct. This included dinosaurs, however. In result of this, the angiosperms dominated while the Pangea continues to break. Now we are towards the present. The Cenozoic Era is our current era. It started 65 million years ago and is still going to this day. This era includes the Tertiary Period and Quaternary Period. The first period of this era is the Tertiary Period. This lasted from 65 million years ago to 2.0 billion years ago. Just like in the Cretaceous period, it was rich in angiosperms as it continued to dominate. It was also the start of the placental mammals. However, in this short time period, there was a rapid evolution in mammal species, more specifically large grazing mammals and marine mammals, as the Earth's climate was warm and mild. The last period. We are currently living in the Quaternary Period. This period started 2.0 million years ago. Different from the Tertiary Period, the Quaternary Period actually had a cool climate. In result of the cold weather conditions, the Ice Age started at the beginning of this period. Mastodons, mammoths, and large carnivores started appearing around this time, and the earliest humans only existed 4.5 million years ago. However, Homo sapiens only appeared 200,000 years ago, and the Earth's climate only started to rise 20,000 years ago. Scientists use two methods to determine the age, eon, era, period, or epoch of the geologic timescales, or order of fossils and rocks. They use relative age and absolute age. We will be covering most of this in a separate part, but relative age tells the order in which events occurred relative to each other, as in this is older than that. This would include law of superposition, index fossils, principles of original horizontality, principle of cross-cutting relationships, types of cross-cutting structures, and faults. Absolute age provides absolute dates for rock and fossils, which are expressed in years. This would include radiometric dating, isotopes, radioactive decay, and half-life. That's all for today's lesson, so see you guys next time.